I will now look into a concentration volume type calculation. The first triangle we already looked at when we done the mass MR mole in the previous video, but now what I've done is I've added an extra two parts to it, which is a concentration and volume. The mole is exactly the same, so the mole is still the mole, but now there's a new way to calculate it apart from mass divided by MR. Concentration must be input as a moles per decimeters cubed, and the volume must be input as a decimeters cubed. A lot of the time you will find the volume is in centimeters cubed. You must divide by 1,000 to get to decimeters cubed. There's also another unit as well, which is meters cubed. That's divided by a further 1,000. So if you think about it, you have to times by 1,000 to get back to decimeters cubed. But remember, volume must always be input as a decimeters cubed. Take a look at this question. I've got 25 centimeters cubed over 0.25 moles per decimeter cubed HCl. I react it with magnesium hydroxide. 18.6 is needed to neutralize it in terms of the volume, because really look at the units, and I want to calculate the concentration. As I know, if I want to calculate the concentration of the magnesium hydroxide, the concentration of magnesium hydroxide is moles over volume, making sure the volume is in decimeters cubed. The moles of the magnesium hydroxide I do not know, but I know the volume of the magnesium hydroxide, which is 18.60, and I will divide that by 1,000 just to assure that it's in decimeters cubed, where I got that to be 0.0186. Now, I need to calculate the moles. So I can first of all calculate the moles of the HCl, and I can do that by concentration times volume divided by 1,000, because the volume again is in centimeters cubed. So it's going to be 0.25 times that by 25 over 1,000. So 0.25 times that by 0.25 times that by 25 divided by 1,000. That's going to give me 6.25 times 10 to the power of minus 3. But notice the molar ratio is 2 to 1. So if I want to calculate the moles of the magnesium hydroxide, I have to use the ratio between HCl to magnesium hydroxide, which is 2 to 1. So 2 moles of HCl gives me 6.25 times 10 to the power of minus 3 moles. So if I divide that by 2, I'm going to get the moles of the magnesium hydroxide, 3.125 times 10 to the power of minus 3. Now all I have to do, take that, put it back into my question mark, and then I divide through by 0.816. Final answer, 3.125 times 10 to the power of minus 3 divided by 0.0186. So if I did do that, divided by 0.0186, I get the final concentration to be 0.168 moles per decimeters cubed.